Okay, class. Today we're going to be talking, kind of closing it up on a section on epistemology, and we're going to be talking about two areas in which it's very important to application. One is the debate over who has the intellectual high ground. That's the we could ask the question, do atheists have the intellectual high ground when it comes to knowledge? That is, do people of faith, people who believe in God, people who are Christians, do we have to concede that we are not in the advantage to those who don't believe in God? Now, if you ask atheists, they're going to tell you, of course. I mean, we're atheists because we're smarter, or our atheism is the result of us following the evidence. That's not necessarily the truth. Okay, and that I'm here to assure you. Though that may have been forced down your throat, or even just assumed as you've gone through K through 12 and even into other colleges, it's just assumed that if you're an atheist, you're somehow brighter, smarter, more intellectually curious. Often atheism is the lack of intellectual laziness and sometimes just intellectual snobbery, this idea that they think that they're superior, and they just assume this without actually following the evidence where it leads, and they reject much evidence based on certain assumptions of atheism. So keep that in mind. We're going to discuss that. The other one is about science, because obviously when you start talking about atheism versus Christianity, a lot of people are going to make the assumption that atheists follow science and Christians reject science, and the history of science has been a war between science. And so in epistemology, there's the theories of knowledge. We want to know, once we start applying this, how does this work out in a little more broader sense? Because most of us don't talk about epistemology. Most of us talk about science and faith, and we don't delve into the particulars of epistemology. But this is where it really starts, the rubber starts to meet the road. Anyways, I wrote a couple articles a few years back. One is questions. It says that it's the title, and I'll put the paper up. It's called "Is Science the Enemy of Religion?" That's one. And then the other one is called, it's right here on the screen, "Can Atheists Claim the Intellectual High Ground?" And I'm going to challenge the claim that science is the enemy of religion, and I'm going to challenge the claim that atheists can claim the intellectual high ground. And so we're going to talk a little bit about that right now in this little this lecture here. And so we'll start off with the idea of or the question, is science the enemy of religion? So one of the first things we always want to do in philosophy, and you've seen this already in the class, is that we want to define our terms. We want to go, well, what's philosophy? Philosophy is the love of wisdom. What's wisdom? Wisdom is knowledge rightly applied to its proper ends. That's the definition we've come up with tentatively. So we ask the question, what is knowledge? And we start talking about theories of knowledge such as justified true belief. We talked a little bit about Warren, this idea of proper function, that if the mind is properly functioning, it draws, not creates, but results in true beliefs. That's Alvin Plantinga. We'll discuss a little of him today. And so we talked a little bit about justification, types of justification, the debate between rationalists, those who believe reason is the best source of justification for knowledge, and versus the empiricists, or the logical positivists. And the logical positivists believe that if one cannot sense it, one cannot know it. Okay. And so we've talked about that, and by and large, the debate between science and say those who believe that religious knowledge is, and we talked about this in our last lecture, the debate between religious knowledge and scientific knowledge, or what counts as science, often centers around the rationalist and the empiricist debate. What counts as justification and the scientific methodology, and we'll talk a little bit about that today. So it's it centers around epistemology, and so yeah, you got to understand there's this debate in the academy over these things, and it's a political debate, not necessarily a scientific debate. So one of the first things we do, anyway, we talked about epistemology and justification and truth. We talked about the three types of truth. We defined truth, gave you three definitions of truth. The correspondence, the coherence theory of truth, and the pragmatic theory of truth. Talked a little bit about belief, just define that. You notice what I'm saying is we're defining our terms. Belief is the psychological disposition to hold a proposition to be true. And so now, if we're going to talk about science, the very first thing we want to do is define the term science. Now, at the beginning of class, we talked about epistemology and its definition. It comes from the Greek word episteme. And then we said that word episteme means knowledge. And in Latin, we have the Greek word, Latin word scientia, and that means knowledge, like episteme. And so scientia seems to give us this idea of what we have now, science. And so it's a word that just means knowledge, okay? And so if we say science is just knowledge, then you're just saying, well, science says, knowledge says. Well, that's an interesting statement. You wouldn't say that. So what we want to do is we want to obviously define what science is, and we ask the questions, well, if just defining the word science as knowledge, that doesn't do the trick. We might want to ask the question, what do all things that we consider the hard sciences will say? What do they all have in common? Say, what does geology? What does astronomy? What does biology, chemistry, physics, and the like? All of anatomy and physiology. We call that a science class. What do they all have in common that they get the word science and say history, music, language, and art? Why do they not get that term knowledge, applied to them? And so if you go to any typical science book, college, high school science book, you open it up, whether it be an astronomy, a physics book, a physics textbook, a biology textbook, even in sociology, who want to lay claim to the social sciences, right? Want to make claim to the term science. They will talk about early on in the first couple chapters, and I use the, not a, but the scientific method. And usually the scientific method is described thusly. First, you say draw a hypothesis. You learned this in high school probably. You draw a hypothesis. You state something that you think is a fact, and then you want to see if that is in fact the fact. Okay, the case. And so you draw an experiment, and I use the case of the glass with the stick in it or straw in it. You put it in, and the straw bends as you put it in. And you say, well, we want my hypothesis is that water bends sticks. And so you drop a hypothesis that water bends sticks. You set up an experiment to prove your hypothesis. And so what you do is you gather the relevant materials that you believe will show this to be true. A cup, perhaps it has to be clear so you can see through it. 2, some water, and 3, a straw or a stick. And then what you do is you fill your cup with water. You drop your parameters, obviously. If this is the case, then this will follow. If water bends sticks, then we will place a stick in there. We'll observe it, and observe to see if it actually bends the stick. And if it does, then we repeat it, okay? And if it's repeatable, observable and repeatable by you and others, then we can conclude that your hypothesis is true. So what we do is we take our glass, we fill it up, we put our stick in, we observe, we look, and we ask the question, do we see through the senses what we claim to be true, okay? And is it justified by the senses, obviously? And when we put it in there, does it bend sticks? And the answer is, well, we observe a bent image, okay? Now, of course, that's presupposing something. That's an explanation right there as to why it's not bent. But so if we were doing this, we're just going, okay, relying solely on our eyesight and the parameters of the experiment, we would say, okay, well, according to our experiment, water does bend sticks. We put it in, we see it does appear to be bent. We take it out, it appears to be straight. We put it back in, it appears to be bent. Straight, bent, right? And we can repeat it as many times, and I can have you repeat it. And then somebody goes, no. It's not bent, it's refraction. Well, the problem with that is refraction is an explanation as to why it's not bent. It's an explanation as to why our sense is not working properly. We don't believe our eyes. We believe, let's say we touch it, we have conflicting senses now. But at this point, we are not now using our senses to determine this. What we are using is reason. We're trying to give an explanation as to why our senses are not working. But if we look at the scientific methodology, which that's all I was really explaining, one could conclude based on the scientific methodology that, light bent sticks. Of course, there's going to be people out there who are going, and why are they going, because they believe refraction. Well, I do too, but I believe refraction as a result of the conflict between senses to show that the senses don't always tell us the truth, okay? The rationalist is going to point to this and say, science, if you use only your empirical verification via the senses unfortunately fool us all too many times, so we have to explain why they're doing so. Well, anyway, so many people will say, what grounds all the sciences is this method, the scientific method? Now, there's a couple questions here that need to be raised. One, is this the only method, or are there other scientific methods? And then there are all sorts of questions having to do with even the scientific experiment I just had. But let's start with that, the first one. Is this the only method? Well, no. Okay, because there are many methods, because not only are there many methods, there are many different goals of science, of the sciences. There can be different goals in zoology and physics and in biology and geology and all sorts of stuff. They're not always saying, if this is the case, I've got a hypothesis and we're trying to prove it. Sometimes they're just trying to classify things. So they wouldn't use this if this is the case, then this will follow the hypothetical deductive method. What they're going to use is maybe the inductive method. The inductive method is nothing more than observations and classifications. And so here we say, I've observed all these animals and I've classified them in zoology. Now, Aristotle's famous for this, right? Classifying different animals and different types. And so you've got the mammals, you've got reptiles, right? Amphibians and birds and stuff like that. And then they start placing them in different categories. Well, you don't do that with if this is the case in this sense. What you do is you observe these features of these animals and you make conclusions based on those observations. You make conclusions based merely on observations. And one of the problems with this is you have to decide what to observe and what not to observe. And you don't do that based merely on the senses. Again, you have to go back to reason to do so, going back to the rationalist versus empiricist debate. You're not wholly using your senses, you're having to use your cognitive faculties to determine what is valuable to what you are observing and what is not valuable, not of value. So you have the thing is not only what is science, but what are the different types of scientific methodologies, but then you have to deal with inside each methodology, just like I was talking about in the inductive method. With the hypothetical deductive method, you have to determine what are the valuable parameters, right? Why did you determine that sight was the best way to determine whether or not the stick was bent or straight? Why did you determine that, the sense of touch was not the best source. And then if you use both, then you have to explain away why. From there, you have to explain away why the two are not lining up. And you can't use the senses to do it. Moreover, it's just not as easy as the method. Now, here's another thing about the method of, the scientific method. The scientific method is not scientific. That is, to make the claim that the only way to justify certain knowledge is through the scientific method. Well, do we know that the scientific method is the scientific method, or that science itself is the only way to know things? Well, if so, prove it. Now, how would one prove that? Can you prove that scientifically? Can you set up an experiment with parameters and make observations of this proposition being a statement that's either true or false? Can you take this method to a laboratory and prove it and repeat it over and over? No. It is actually a philosophical statement about how one ought to conduct themselves in determining what is true or false. And it is actually based on certain philosophical assumptions. One, that the senses are the only way to know things. Now, of course, there's also all sorts of violations of this in science, where, when you take that scientific methodology that, you can only know it through the senses or through observation, you have to understand, again, like I just said, you can't observe that. You can't observe the truth of that. But I think there are all sorts of other problems with it. Not only can you not observe it, they also inject all sorts of violations of that. So the assumption of mathematical truths, the assumption of logical truths, these are not physical things that you can observe. The if A then B, A therefore B, that cannot be shown through physical observation, through the senses. The truth of math, that 3 is greater than 2, is not observable through math. Now, objects are observable, but the truth that the quantity of 3 is greater than 2 is not observable. So certain, they call math the language of science. Great. The great thing about that is math is not observable. So for the rationalist just needs to point out that, look, you're believing in certain non-physical principles that exist when denying that non-physical principles exist. So it's in one hand, they are doing a good thing by using this, but on the other hand, they're doing this quite arbitrary rejection of certain things while they accept that very thing they reject. We reject all non-physical aspects of reality, yet we're going to prove it with math. A non-physical aspect of reality are the laws of logic, right? So anyway, even if they say, that's just language about reality. Well, again, there's language. Language is what? It's a non-physical thing. I mean, sound waves are a physical thing, but the content of language is not. So anyway, so that we've got problems with not only the definition of science, but its own application. Let's see what else we got here. I'm trying to scroll through it. My mouse is not. Empiricism. So what I want you to do is I'm going to have you. I'm definitely going to have you read this, but let's talk about science and its goals. What are the goals of science? Is science always truth? Or is it just to explain? So for example, when we were talking about the water in glass, what we're trying to do, many experiments may not be trying to ask whether or not water bends sticks. I mean, that's kind of what I use as a joke. But others, you might ask the question, we're going to use this experiment to explain something. And they come up or create an explanation for why. It's called the explanation of the phenomena. The phenomena is what we're experiencing. And so they're going to explain why our two senses are not in line with each other, why they're competing, why one's saying the stick is bent, why the other is saying that the stick is straight. And so they come up with a theory called refraction, that what we are seeing actually is light, and the glass, the water, creates an image, and the image is bent. The light is bent, and we are experiencing the phenomena as the light that we're experiencing, and so it bends light, and thus the stick's not actually bent, the image is bent. Okay, that's all fair and well. I think that's a good theory. But again, keep in mind that the theory there, not all things in science are just about truth. It's about explanation. We need to explain why we are seeing this. Why on earth is the stick bent when it shouldn't be bent? Okay, or why at least we're perceiving it. Who has a problem? Okay, so there are different things, and solving the crime is a scientific endeavor, right? Who did it? Who done it? Because CSI, we've all seen crime scene investigators in the movies and shows about it, and they make use of science, and so they're asking a whole different set of questions. Okay, all right. Now, the great thing about science is science interacts with other disciplines. Science interacts with art. We could take the technology of art. Oh, by the way, here's something that needs to be mentioned. One of the reasons people trust science so much is because of its successes. Okay, the success in, say, technology. We can build things, we can power a city, unless you're in Houston during this week. We look at the stars, and we create medicine with it, medical technology, and we build houses through engineering, great buildings and great things through the use of all this great technology. So we have great trust and enthusiasm for technology and science, and that's a good thing. Just as that man can discover and man can create, and so we trust all these things. But let's not get arrogant, because there's far more that we don't know than what we do know. Another problem with it is to go on and say all this confidence we have in science. We have to understand that there are far more failures in science than there are successes. So not everything that is science turns out to be true. Okay, so you can start off with a lot of times. One of the goals that I didn't mention earlier is to falsify certain things, to show that certain theories are false. Okay, that it is false that light bends sticks or water bends sticks. Okay, so people would do that. Okay, and so there's a lot of competition in science. Now, let me give you an example here. During COVID, there's been a lot of changes. So for example, you hear the CDC say one thing one week, and the next week they say another. Dr. Anthony Fauci says, you don't have to wear masks. They're not going to do anything for you. Then he went to wear a mask for sure. Don't not wear a mask. And then he went back to, well, I really don't know about this mask thing. Now he's up to, no, you got to wear 2 masks now, and that's kind of crazy. So, and then you got, watch out for the kids. They're going to get sick. And then also, why aren't the kids getting sick? Then you go, well, we got a couple kids that are getting sick. And so science often has, here's the thing. Science doesn't conflict with itself. Scientists conflict with themselves. We have theories. Some theories are false. Some theories are true. Some observations yield true beliefs. Some observations yield false beliefs, okay? Some science is used merely just to falsify things. Some science is used just to explain things. All right? So we have to keep these things in mind. But let's go to some of the applications of science, because science, like I said, you can see how broad it can be. Science can be applied to art. And we can say, how do we restore this painting? Okay. Now, asking whether or not the art is beautiful clearly is not going to be something in the realm of biology, chemistry, or the like. Chemistry is not going to tell us whether or not the Mona Lisa is a good or bad painting. Chemistry might come up with some weird epoxy to keep put a varnish over the top of the painting to keep it from deteriorating. Or maybe we could determine a type of chamber that we could put this painting in, which I think they have that, maybe, I don't know. How do you determine what temperature and what humidity you keep this painting at in this controlled environment to maximize the lifespan of this painting before it just disintegrates to dust? That's science, and that's valuable. Not we apply it to art, but it does not have to do with the beauty. One of the transcendentals, right? Truth, love, and beauty. And so in that regard, it's applied to certain things. But what about other fields like religion? Because that's really where we're going with this. Can you apply science to religion? And the answer is yes. How would you apply science to religion? Well, you could use certain fields of science, such as archaeology. You could use certain fields of sciences like chemistry or cosmology, or I should say astronomy and genetics. You could look at all of this and ask certain questions about religious statements to either falsify them. We could falsify certain religious statements, so we say, well, we don't need to believe that one, or we should believe this one because it actually adds truth value to it. It actually adds evidence and justification for us to believe it. So archaeology, so we look at the scriptures and look, it talks about, civilizations that lived thousands of years ago. And then archaeologists go, man, I don't believe that. And if it is true that the civilizations lived thousands of years ago, we should be able to go out there, do an archaeological dig. And if we find these buildings, these places, these remnants, then we can conclude and we can make certain dating methods and determine how long ago these civilizations were there, and to determine whether or not it is true that, say, these civilizations actually existed. And the great thing about that is there's great archaeological evidence that has taken place, dating methodologies that have been used, digs that have found sites of biblical civilizations. And the great thing about this is it just keeps happening. There's, they'll be looking for years, and all of a sudden they find they've been digging in the wrong place, and all of a sudden they find something. They find pottery, and they find writings, and they, stuff like that. They find scrolls, like the Dead Sea Scrolls in Qumran, and they make use of science in this. They can date these things. They can make, again, like the art, they could use technology to preserve these things, and they could use certain other fields of science to learn about these things and about these civilizations. And so science can be used in this. And one of the great things about it is it's not just determining whether or not these civilizations existed, but they could determine whether or not the biblical record is true by use of science. And so science in this regard is not the enemy of religion. In fact, it's quite friendly to Christianity in that it has shown that many of our beliefs about certain civilizations and of God, where of the people with whom God's people interacted, existed. We could talk about crucifixion. Did it exist? Yes, we can see that throughout not just the historical record, but through archaeological records. We could see bones with spikes still put in them. We could determine what an agonizing death it would be scientifically and all of that. So religion, specifically Christianity and Judaism, have a great deal to learn about themselves from the use of the different scientific fields, such as biology, such as genetics, that's a great one, such as physics, and such as archaeology and the like. Okay, now there are certain claims that can be made by Christians, even making use of zoology and the like, and they have been. I want to say one last thing about science, and then we'll scoot on over. Do atheists have the intellectual high ground? Okay. The thing is about one of the branches of science that has been really exciting is physics, in that, you know, we talk about the Big Bang, and a lot of people believe that's how the universe came to be, and that the universe came from nothing, you know, into something. Okay, and the initial event was a Big Bang and the universe exploding. And a lot of people think some atheists came up with that. What in reality it was his name is Monsignor Lemaitre. Now, I'm not really good at my French pronunciations, but he was a Catholic priest and you know, physicist, and he came up with a theory. He was mocked, and so they gave it the name the Big Bang Theory. Now, the Big Bang Theory just so happens to be an insult, but it shows that the universe is expanding, and if it's expanding, it's, you know, you go back in time, it would be contracting, right? And they suggest that it came from nothing into something, and the initial criticism was that this is just an excuse to show that the universe at one time did not exist, came into existence, came into being, and if it had to come into being, it couldn't cause itself, therefore it had to have what's called a first cause, just Thomas Aquinas, right? This first cause, this God that called something into existence from nothing, and so they were mocking him. Well, now it just so happens to be the consensus view among those physicists who talk about how the universe came into being. And obviously it's funny now that they try to use it as, you know, evidence of how the universe came into existence without God. Originally it was critiqued by the atheists as just another excuse to inject God into science. But now that's the mainstream view that that physicists hold about the origin of the universe. Okay, with that, I think I've been going quite long. This is kind of a long lecture. Maybe what I'm going to do is break this into two. We'll call this one just Is Science the Enemy of Religion? I basically rambled all over my article. So what I want you to do is read the article. I think it's much more articulate than this lecture. Watch the lecture, read the article. I think you'll get a much better grasp of what I'm trying to say. So with that being said, I'll let you go. I'll ask some questions about it, and the next lecture I'll post up will be about the does atheism have the intellectual high ground? We'll pick up from there. All right, with that being said, you have a great day, and I'll put all this up. Thank you. Bye.